Okay, like I was saying before, we'll cover the construction of the space station. Over 20 years of construction. We're going to compress this in, hopefully in an hour. And this, of course, involves amateur radio. I made these presentations really for a school could do it. So it's almost like I have two different presentations. One that really concentrate on amateur radio, which is this one. Anyway, we'll start. I have a little laser beam here, and we're going to continue on. Now, here's another view of the space station, and they use different call letters. If you're in the United States, we use NA1SS. If Russia's making contact with schools, they'll use RS0ISS. Or you have our European Space Agency's call letters. They use a Belgian call letter, OR4ISS. So anyway, looking at the space station, before we go through all the different modules, it's good to think of the space station like one big airplane. Like here's the front where the pilot would be. Here's the tail and the back. And then you have the truss sections going from one side to the other. And now this would be the starboard side, and this would be the port side. And yes, there is an up and down. As the space station goes around every 90 minutes, the space station actually revolves every 90 minutes. So it's always facing in the same direction. So let's continue on. Piece number one was the Zarya, also called Dawn. The Zarya, also known as the FGB, which is called a functioning cargo block, launched in November 20th, 1998 on a Russian Proton rocket. It had solar panels, guidance control, and propulsion. Now, Zarya is on the left, and on the right you have astronaut William MacArthur inside Zarya, March 21st in 2006. His amateur call sign is KC5ACR. He was having a scheduled contact with Sir James Lockheed Elementary School in Calgary, Alberta, Canada. He's using the 2-meter Ericsson MPX handheld radio. That's the first ones that were approved by NASA and Aries, the amateur radio on the International Space Station group. The next one that went up, see, the Russians launched first, and then we sent the next piece up, which is called Unity. It was also called Node 1. It was the first module launched by the USA for building the International Space Station. Launched on Space Shuttle Endeavour, STS-88, in December 1998. Unity had 2 PMAs, pressure mating adapters. Now, these things are important. They were attached when launched. PMA 1 is used as an adapter to connect Unity and Zarya together. And then pressure mating adapter 2 over here will be used for future shuttle dockings. Unity has 6 ports where different modules can be connected. Each port has a common berthing module. See, each one of these things are called common berthing modules. The station will eventually have a total of 3 PMAs. 2 will be used for the shuttle and commercial spacecraft crew dockings. The space station would eventually have 3 nodes to connect many more modules. So this is called a node, and there'll eventually be 2 more. And each one has all these different connections that it could be made, common berthing adapters. See, when you dock with this, you just dock, and the system pulls itself together. With this, you connect with it, and there's 16 bolts surrounding this on these common berthing adapters. So it takes a very long time, and eventually they have electronic motors on each bolt that tighten everything up to make the seal. With these, you could just dock and undock quickly. Okay, we'll continue on. Here's another view of the Zarya with the Russian solar panels, pressure mating adapter number 1. You have the first Unity that was sent up with pressure mating adapter number 2 attached. And now there was the third module that went up, and that was also sent up by the Russians on a Progress rocket. By the way, Progress is their biggest rocket. Zvezda module is 43 feet long. It's the Russian main living quarters, has living, bathroom, and eating accommodations. It has a refueling system with thrusters able to raise the orbit of the space station. By the way, here's the thrusters down here. There's one here and one here. This is a docking port. This is not an engine. This is the small thing here and the small thing there are the thrusters. So after the crews arrive, they always take a group photo and hold interviews in that module. If you'll see it on TV. A new crew gets there and they all get together. You'll see the 3 that were there and the 3 that just joined them, and they have a news conference. So now we'll continue on. Here's another view of that same setup, and this service module has a docking port for Soyuz crew and Progress cargo ships. So again, it could dock here. You could either have a crew vehicle or a cargo vehicle. For Russia, they're called Progress. So they look the same. You can't tell the difference by looking at it, whether or not it's a Soyuz crew or a cargo vehicle. Anyway, this is the first ham system up here that went to the ISS. Aries laid it out on the table, and it went up in 2000. And you had the Ericsson MPX, the HT, which had 5 watts with the power supply, controller, earphones with a mic. The radio was installed first in Zarya. So now that was Zarya is the first one that went up. Keep that in mind. Zvezda docking port is attached to the Zarya module. So this is Zvezda, a big unit attached to Zarya over here. And Zarya, by the way, is like the machine room in a building. It has all the stuff in it, but the Zvezda has all living quarters and CWs, which is crew quarters. So again, you have a spacecraft from Russia, Soyuz. You have the Zvezda, and then you have their solar panels, and then that is connected to the other Russian piece, the Zarya, and that in turn is attached to a pressure rating adapter. It's hard to see here. And then here's our Unity module that was sent up, and here's the pressure rating adapter number 2. Now you can see they have a temporary Aries antenna that was installed on Zarya. So this is where the first ham shack was located. But after a certain amount of years, they relocated it back to here. They wanted to get it out of the noisy machine room, the Zarya, and bring it over to Zvezda. So let's continue on. Now here's a close-up view of what they did. They actually did an EVA. The Russians went outside, and they had a lot of things to do. But one of the things that they did is they went back on the service module, the Zvezda module. This is their living quarters, and they installed 4 antennas: one here, one here, one here, and then another one on the other side that you can't see. And what those antennas are, 3 of them are 2-meter antennas, and also the dual band antennas. They also work on 70 centimeter. This one here is 8.5 feet long, and they had plans on eventually hooking HF up to it, but as far as I know, that was never done. But it's there. So now, that's the permanent location. By having all those antennas around, no matter how what the attitude of the spacecraft or the space station was, they'd be able to have contact with the Earth without blocking it out. So that's why they had all those antennas. And here's a Doug Wheelock, KF5 BOC, Expedition 24 engineer. Give you an idea, we're up to Expedition 66 now. Each time they go up, it's another expedition with a new crew. He used the ham radio in the Zvezda service module on the space station in 2010. So that's when it was relocated. You can see he's got the mic here, and then over here he's got the this is the head. It's a detachable head, and the rig is up here, located over here. By the way, Gary, you can see my laser beam, right? Okay.
Yeah, for sure.
Okay. Okay. I wasn't sure if that was coming through. Okay. Yeah. Now have the ham station. This is the ham station inside the Zvezda module. Again, this is where they live. This is where they eat. This is their Russia's big module. and they installed a 25 watt Kenwood TMD 700E. It's VHF, UHF, of course, FM, and this was their upgraded ham radio setup. Here's the mic. Again, here's the detachable head, and the rig is up here. And you can tell it's the Russian station. They love Yuri Gagarin, and I have a picture back here. And, you know, he's like their patron saint. So we can continue on. Here's another fellow. This guy's a Russian, newly relocated ham shack that went from Zarya module to the Zvezda module. Cosmonaut Maxim Surabey, and a Russian school contact using the Russian ISS call sign, RS0ISS. What's interesting, he doesn't have a real call sign when he's back in Russia, but Russia gives their cosmonauts the right to operate the ham rig when they're up there. And when they do, of course, they just use the Russian call sign, RS0ISS. So they always give them the okay to do that. You know, if they don't have a call sign, but this guy is a part of that group. There's maybe half a dozen guys that have gone up there that they've done that with. And now we get involved with the first Truss section that was sent up. Shuttle Discovery SDS-92 delivered the Z1 Truss section and attached it to the Zenith, or the top part of Unity. This shuttle brought a third PMA with them for future dockings. They connect the pressure mating adapter number 3 to the bottom, or the nadir part of Unity. Again, there's a top and bottom to all this. So if it's looking up, if you're inside and you're looking up, that's the Zenith part. If you're looking down, that's the nadir part. Here now you see all 3 pressure mating adapters. Here's the one that connects the Russians to the USA side, and then you have pressure mating adapter number 2 and pressure mating adapter number 3. And now the Z1 Truss has 4 massive CMGs in it, control moment gyroscopes, that control the attitude of the space station. More on that in a second. It also has the communications equipment to transmit to the TDRS satellites, the tracking data relay satellites that NASA has put up there. There's like 11 of them up there now, situated around the globe, which would then, from there, they can connect to mission control. It also has plasma connectors to neutralize any static electric charge that builds up on the station. So the top of the Z1 Truss will eventually connect to another truss piece. So let's continue on. Here are these control moment gyros that I was talking about that are located inside the Z1 Truss. These 4 things here. The 4 CMGs, or control moment gyroscopes, in the Z1 Truss controls the attitude of the station. They need at least 2 to work. So on the right, you have Tsuchi Noguchi, KD5 TVP. By the way, he's from Japan, but he got his call sign when he was working with NASA in Houston. They installed a new CMG because one of them was broken. The broken one the broken one was returned to NASA in 2002 on STS-114, the Discovery mission. Now they are 600 pounds each and contain a steel wheel that weighs 220 pounds and spin at 6,600 RPM. So you can imagine these things spinning. And they stay in one place, but then motors turn around them. And then by those motors turning, that will actually turn the space station one way or another. Of course, they need 2 to work. Right now, presently, they are all working. But you could see this astronaut was attached to the Canadarm here while doing that work. So, by the way, the control moment gyroscopes are different than the reaction wheels. Reaction wheels, they spin up and spin down. reaction wheels are used like on small satellites to control their attitude. On something big like this, you want something like the control moment gyros. And you can probably do a whole presentation on them itself. It's really fascinating on how they work. Now here's the P6 Truss, which was next that flew on Endeavor. It was attached to the Z1 Truss, the one that we just talked about. It had the first set of large solar panels that would supply 40 kilowatts of electrical power to the station. Now, by the way, that would be equivalent to 10 homes. The average home is, they say, is 4 kilowatts of power. It also had radiators to get rid of the heat that accumulates inside the space station. The panels are 230 feet long by 39 feet wide. Now these things, this is the first set. Eventually there'll be 3 more like that as time goes on. Now Atlantis brought up the next USA module called Destiny. It's like the other, similar to the other modules. It was brought up in the 60-foot long cargo bay. All the modules were brought up in that. And you can see here astronaut Robert Kirby on an EVA working on Destiny. It was attached to the Unity module. To do that, the pressure rating adapter number 2 had to be moved forward. Destiny is 28 feet long and 14 feet wide. So every time they bring a new module up, if they're going forward, they need to relocate that pressure rating adapter that they always enter the space station with. So in this case, that's what they did here. He's preparing that. He's releasing bolts and all kinds of things that are held in place that hold this in for launch during shipping. But eventually he gets to the point where him and another astronaut doing an EVA will set this whole Destiny up. And this is it's a science module for the United States. His Destiny being removed by the cargo, from the cargo bay using the robotic arm. Here's the robotic arm. Grabs a hold of the whole deal, removes it from the cargo bay. This is the back of the cargo bay. Here's the rocket engines on the shuttle. And eventually they will install that to the front end of Unity. And then on the front end of this, they'll put the pressure rating adapter number 2 back on that, so that they'll be able to dock the shuttle with it and allow astronauts to go in and out of the space station. This is inside of that same unit. You can see all the stuff. I mean, they've got more screens and computers and equipment, and this is our science module from the United States. All kinds of experiments, hundreds of experiments are done in here on a regular basis. So it's a 28-foot long lab, and it was birthed to Unity, and back in 2001. So this added another 32,000 pounds. Each time one of these modules go up, they're usually in that 30,000 pound category. But this is the way it looked in 2001. Again, here's that Destiny. Here's what we've seen so far. Here's a Russian spacecraft attached. Here's the Zvezda science and living quarters for the Russians with their solar panels. And then you had the functioning cargo block, Zarya, attached here. And then in between here, you have the pressure rating adapter, which adapted the Russian side to Unity. And this is Unity here. And then in front of Unity, you now have Destiny, the last one that we just saw brought up. And you can see they relocated the pressure rating adapter number 2 here, and pressure rating adapter still down here, number 3. So that's you can see here's the Z1 that we talked about, the Z1 Truss section that has all those control moment gyros in it. So we'll continue on. I was talking about the docking, and that's what they do. They always use these pressure rating adapters to adapt to dock the shuttles. The Russians always dock on their Russian side, and we dock on the U.S. side. So you can see they're docked here. And to get inside, you have a crew in here, maybe a crew of 7, and there's a hatch that they go through here a little tunnel, and then the tunnel goes up into through the pressure mating adapter into Unity, and then they could occupy the space station, go anywhere they want after that. So here's another view of the same thing, except a different view of it. Again, this is where the shuttle docks to the pressure mating adapter. The tunnel is down here below where my laser light is, and that's the story on that. So it gives you a better view of what I'm talking about. And then now we go into the Canadian robot arm, which you saw a little bit of it before. The arm is 57 feet long, has 7 different joints. It's controlled by astronauts on the ISS or by mission control on Earth. You know, the astronauts could be sleeping and mission control could be working this thing. It has 2 end effectors that have data and power connections that go to it. It can inchworm to different locations on the ISS, or even go for a ride on the mobile cart or mobile remote-based service system that rides on a train-like track. It could grab cargo resupply craft like the one below, the Kunatori HTV. They usually call them just the HTV, but there's been 9 of these things that have been sent up in about 10 years from Japan. It was sent up by Japan, and it holds a lot of cargo. I think they can go up to 13,000 pounds in that, which is quite a bit. It's twice the amount that the Russians send in their Progress cargo vehicles. It could hold your robotic arm could also hold the astronauts. They hold it by their legs. It connects to this end effector, and this gadget here attaches to their legs. And what you don't see here is there's like a little pole going up, and it's actually attached. You know, he's grabs it, attaches to his suit. So he's just not dangling it by his feet. He's kind of like attached here. This piece attaches to that. So he's pretty safe. So let's continue on. Now, below pictures, these pictures down here are what the end effector does. On the right is a picture of an end effector up close. And this one's a little further away. It has these 3 cables inside, and these are around 5/16 in diameter. So it's actually a heavy cable. And you can see one is attached to the outside, and then the other part is attached to an inner collar. So as they spin, they get closer and closer together. This is called a grappling fixture. Over here on the left, the grappling fixture has this grappling shaft coming up the middle. It's a long little piece coming out, and it's like a little round head on the top. So what happens is the robotic arm will go over that piece, and then it'll start turning. You can see eventually the cables get closer and closer, and it grabs a hold of that grappling shaft. And then from there, you can see it's got depth. It will actually start pulling it inside the end effector. As it pulls in, you see these 3 pieces. These are elevated. These little pieces here, and they're the same shape as these 3 over here. So as it pulls it in, these 3 enter here, which makes it very secure. You also have these 4 outer pieces over here, and that's to supply data, power. If need be, some of the units that they pick up need to have power and data connected to it. Some of them don't. They don't have that. And they just want to relocate, a large piece of equipment. It'll have this grappling fixture without these data points. But these points here, after it's attached, these 4 pieces over here have little pieces that expand, and they actually plug in automatically to these 4 connectors. So that's how that's accomplished. The end effector is remarkable too. On the robotic arm, they have 2 of these. There's one on one end and one on the other 57-foot long piece. So they could either one will work. Now we get to the Quest joint airlock. Quest is 20 feet long, 13 feet in diameter. It was launched by Atlantis before installing Quest, all NASA spacewalks were done using the Space Shuttle Airlock. So I showed you the airlock before on the shuttle. That's how you would do an EVA. But now, once this unit was installed, they could now do EVAs from the Quest lab. So this module here we go. With Quest and the EVAs could now be done without the space shuttle attached. It has 2 rooms, one to don the spacesuits, and another is the airlock. Attached to the outside of Quest, there are 4 massive tanks that they don't show them here that have either oxygen or nitrogen in it. Every time you do a spacewalk, there's some atmosphere that's lost. Even so, they pump down the air inside and pump it back into the space station to save it. You can only pump it down so much, and you wind up with they call it 13 kilopascals, which is really equivalent of like 1.5 pounds of pressure. Still a lot of air, and that has to be vented out. So if you see them doing an EVA, they'll talk about venting, and then once the venting is done, then they could open up the outside and go for a walk. So you have 2 astronauts here getting into their spacesuits. This is the main big room, which would be this room, and then they would enter into the smaller piece over here, and the door would be closed. They have a door here that closes like a garage door, and that would seal them in, and they would be able to do a spacewalk at that point. And they always have an astronaut helping out, either when they're going out or coming back. Going back to the Russian module, Russian section, you have the Pirs Russian module. This is Pirs here. It was attached by a Russian Soyuz spacecraft and automatically docked to the near or Earth-facing port of the Russian Zvezda module. It is used for Russian spacewalks. It also has a docking port that can be used for Russian cargo or manned spacecraft. Now, so the left picture where I have the dot shows where that's Pirs, and then it shows a Soyuz spacecraft that's docked to it. And the other picture is what the ISS looks like at this point of construction. You have your Soyuz, your Zvezda, Zarya, pressure rating adapter. Behind this unit, you have your Unity, you have Quest, that's the one with the 2 rooms we just talked about. And you have Destiny, pressure rating adapter number 2, and here's your Z1 with your control moment gyros. So we're pretty much caught up. The thing about Pirs is that's it was sent up, like I said, 2001. They're going to retire this, and they say this is a progress ship right now. They have one attached to it right now the way it is, and within the next month or so, they're going to actually disconnect this completely from. They're going to do away with this module, and they're going to bring it over to the Pacific Ocean and deorbit both of these things and burn up in the atmosphere. But it will be replaced again later on this month or next month by Nakao, which is another module, which means science in Russia, and that's going to replace this. So that's presently in the news now, and that's going to be another big module, similar to what this Russian one is. The Zvezda. It's going to have another bathroom. It's going to have more living quarters for cosmonauts. Another kitchen, like I said, most importantly, another bathroom. They can't have enough bathrooms on the space station with the additional people that are now flying on it. For instance, right now we have 7 people up there. Okay, now to get involved with the next couple of slides, we have there's 11 of these things, 11 of these truss sections. So they all support these giant solar panels with massive 48 rechargeable nickel hydrogen batteries, and that's right, they're nickel hydrogen, not nickel hydride. They are called nickel hydrogen batteries. These batteries weigh about 20,000 pounds. By the way, they've all been changed out in recent years, and now they're using lithium-ion batteries. So they've gone from 48, they've cut that in half to 24 batteries, 24 lithium ions. Over the last 3 or 4 years, they've done spacewalks, and so that, they've modernized things. Now the SOARs, or the solar array wings, That's what they call solar array wings. And all the modules would now grow to be larger than a football field after these things are put together. The first section is called the S0. That's this one. It's the center main supporting structure of all the truss sections. It is attached to the top of Destiny module using 4 stainless steel struts. The S0 truss was launched on Atlantis in 2002. It also had a track that the mobile remote base service system will eventually ride on. The photo on the right is S0 carried by the station's robotic arm 2. And this truss piece is 44 feet long. By the way, I keep saying Canadian arm number 2. Number 1 was permanently put on the shuttle, so that's why this one's number 2. Continue on. Again, here's the 57-foot long Canada arm 2. Here's the mobile base service system that rides along the track. And then here's Dextra. This piece is called Dextra. It's got, you can see, here's a closer view. It's got 2 arms. Here's arm 1, here's arm number 2. And then it attaches the, up here, you can see one of these grappling points I talked about before. And that's where the robotic arm attaches to it. And then this thing could pull out batteries. It could open, close ammonia valves. Well, it does all kinds of work with these robotic arms. They have all kinds of different tools that attach to this thing. So instead of just a big grabbing machine, it's almost like a robot. By the way, at the bottom, they have another latching end effector. So they don't have to, if they need to grab a hold of another big piece of equipment or module, they could do that without disconnecting it here. They could just use this latching end effector. So let's continue on. The next 2 truss sections are called the S1 and P1, which stands for starboard and port. So you have your port side and your starboard side. And again, these are 45 feet long. They were brought up in October and November of 2002, and they were attached directly to 0. So here's 0. You have number 1, also number 1 on that side. Continuing on, right after that, you had something called SARG. It was a solar alpha rotary joint, and they consider it. They call it number 3 and number 4. So you had a port 3, port 4, and then there's also on the opposite side of the space station, you have a starboard 3 and starboard 4. So it came up in one unit. And what it is in here there's a big motor. So this is as big as maybe a Volkswagen Beetle, this whole setup, and it rotates once every 90 minutes. So you have this motor. I think the motor is like, you can't see it. It's attached to the outside, and there's some kind of a big gear on the inside, and that rotates this thing. So it actually rotates slowly, but this way it's able to keep these solar panels always facing toward the sun. And they also have there's another motor setup over here to actually change it. This is on the alpha, and then there's one on the beta. So you can change it on the x-axis and also on the y-axis. And there's 2 of them, and they were directly connected to pressure to the port number 1. You'll notice there isn't a port number 2. They had the S0, they had port 1, and then they skip port 2, and they go to port 3 and port number 4. Number 2 is dropped. Number 2 is going to have thrusters on it, and that's how they were going to make sure the station always stayed in orbit. Eventually the station loses altitude. Those thrusters were going to eliminate that problem. But they realized the Russian thrusters in the back that I showed you earlier in the beginning were plenty to do that. So they just eliminated PS. They eliminated P2 and S2. We'll continue on. Here's a closer look at that. Here's the SARS joint, and I think this is the part of the motor system, and it drives this whole setup around. This part is attached to this main part of the space station. And this part is the part that rotates. And eventually these all fold out like a big accordion. They become the soars or solar array wings that are eventually 230 or 239 feet long end to end. And then this motor in here, that's the beta motor that would spin it on the y-axis, and this spins it on the x-axis. We'll continue on. And they had a short filler pieces in here and over here, and that was they had a P5 and a P6. They were 12 feet long. You know, you can only bring up, you know, so long, you know, of these truss sections on the shuttles. So these pieces were bought up separately, fill pieces. The idea was to get from this to the next section where you're going to have another solar array out here, and you needed the fill piece over here to eventually have another solar array out here. So we'll continue on. Then after they didn't finish with the solar panels yet, but they said, well, let's start bringing up more modules, and they did. They brought up Harmony. That's this one here. Harmony attaches to Destiny. It was the next big module to be brought up, 24 feet long, another 31,000 some odd pounds, and it was attached to Discovery. It was birthed to the front of Destiny module. So here's Destiny and here's Harmony. By the way, they use the word birth. Anytime you make a hard connection like this on a common berthing mechanism without these pressure mating adapters, that's called berthing. Here it's docking. If something docks to here, it's docking. So that's the difference there. Because it was a node, it also has 6 different ports. So you had one here, one here, one here, and another one below that. And by the way, here you can see these grappling points. You can see that's where the Canadian robot arm grabs a hold of these things to install them. We'll continue on, and it just the front end of what we were doing so far. So you have Destiny, you have the new Harmony one coming up. We're going to talk about Columbus in a second, and Kaibo, which is from Japan, in another second. So first, this is the Harmony module that was brought up, again, in the cargo bay. They had to, again, relocate the pressure mating adapter number 2 to the front before they installed it. This way they could always dock to the space station to let crews in and out. Continue on. You have the next one was Columbus. Here's the Columbus module. Now this is important because this is going to become the next ham shack. Columbus was next to be put into operation. It would become the second module used by Aries on the amateur radio on the International Space Station. Over the years, the ham radio equipment has been upgraded. They operate phone, digital modes, as well as slow scan TV. Columbus is 22 feet long. The module is the European Space Agency's contribution to the station. So you can see what we have here. Here's Columbus. Again, that was put out by ESA, or the European Space Agency. That's their contribution. So you can see it being installed to Harmony, different views of it being installed. And then we go over to Randy Bresnak. Randy, believe it or not, is not a ham, but here he is installing a 2-meter, 70 centimeters. So it's a dual band antenna, bolting it to the side of Columbus module. So that when we make a contact in the States, most times we're using this unless something's broken here, then we'll borrow the Russians module, Russians ham radios station in the Zvezda unit. So I thought that was a great picture. Now, again, this is inside the European Space Agency Columbus module. This is where our ham station is, and it's located back here. I'll show you that in a second, but that gives you a view of what the inside of Columbus looks like. It's, again, attached to, if you go through these doors, you're attached to the Harmony module on the starboard side. Here's astronaut Samantha Christopher Eddy. She's got the call sign IZ0 UDF from Italy. and she operates the old Ericsson HT ham station using the call sign NA1SS. Even so, she's got a call sign. They always use NA1SS when you're making contact with the space station. She's in the Columbus module. The door leads to the port side of Harmony, node number 2. So we continue on. Now this is the upgraded radio that's now in Columbus. This is what they use today. And again, you can see the Kenwood microphone here. You've got the detachable head, and up above is the rig itself. And they're now using the Kenwood TMD710GA. Generally, they put out 25 watts. Now, next big module was a big module, and this had to be brought up in 3 pieces. The Kaibo was the next major set of modules installed as part of the ISS. It is one of Japan's contributions to the ISS. JAXA, or the Japan Aerospace Exploration Agency, that's their version of NASA, is the one that built Kaibo, which means hope in Japanese. It took 3 shuttles to bring the 2 modules and 1 exterior section to the station, all in 1 year of 2008. The pressurized module is the main piece. That's 36 feet long. The other ones were a lot shorter. See, this was a lot long. Again, they were all 14 feet in diameter. Most interviews on the US and the ESA side of the space station take place in this section. So when you see a clip on the news, or if you go to NASA and you're seeing an interview with either our astronauts or the European Space Agency astronauts, this is where they are. They're always in this module. The smaller Kaibo module, which is used for storing science, that's one up here. Experiments and other supplies located on the top, and that came up on a different shuttle. And then they have the outside experiment sections, quite large. They call it the patio. It even has its own robotic arms, I think 35 feet long. The big module has an airlock that can be used to put experiments and satellites up to the size of around microwaves inside of it. And it comes out here. They use the robotic arm. They can put it here, or they can launch it into space with the robotic arm. That's the story with that. And I have another view of it being after it was attached to the Harmony module over here. This is the Harmony node. So you have Columbus, is where our ham shack is. The antenna is located down here somewhere. And then you have the Japanese module over here. We'll continue on. With Kaibo nearly complete, there was one solar array wing, the P6 section that was temporarily installed to the top of Z1. Earlier in the presentation, we saw that. So that eventually had to be relocated, which they did. This truss section was over here, was attached to the Z1 piece, and they did one of the shuttles. They did a lot of EVAs, and they transported it from here to here using the Canada robot arm, and eventually another set eventually winds up here as well. So you can see, the different modules that are located there, and the truss section getting bigger and bigger. You have the two other Russian modules that also are in the back, and that's called the Poisk and the Raspet. There were 2 more Russian modules. They were sent to the ISS. Poisk was launched on a Soyuz rocket, and then we did them a favor. We launched our Raspet on a space shuttle, Atlantis. The both used as science labs, as well as docking ports for crew and cargo. They also have been used as an airlock. That's how they do their EVAs out of these things. Below, on the left, is Poisk. That's how it got brought up by this unit over here after it launched from Kazakhstan. And when they launched, this piece eventually attaches to the space station. This separates, and they throw this away. This burns up over the South Pacific. All right, now you have inside, of course, this gives you an idea of the size of it anyway. There's a Russian inside of one, two Russians. They could do an EVA out of that. So you can see they're a lot smaller than what we have in the United States. Compared to our Quest module that we go in and out of. And now you have the RASFET. The RASFET module is larger than the POIST. So here's the RASFET. Here's the POIST module. And you can see the locations. So you have RASFET. This is the piers that they're going to separate probably within a month, and eventually replace this with a big, large module that should be coming up in a couple of months. And then so it'll still be able to do EVAs out of here or out of here. So we'll continue on. We have the Tranquility module. We're almost done. The Tranquility module was the next that went up with the cupola attached. Here's the cupola. This thing is the viewing port for the International Space Station. So it was sent up like this because it had to fit into the space station. They really wanted to put here. So after it got into space, they disconnected it here using this grappling fixture with the Canada robot on number 2 and installed it over here. And then they installed it onto the space station. I'll show you that in a second. And now here's a new location on the side of Tranquility. It's called the Tranquility module. Also another node, six different ports on there. Anyway, here are all the windows. There were these trapezoidal windows. There's 6 of them. And then on the very top, there's a 1 meter diameter glass that they could look at as well. And here's a cover that would cover it. And here's these covers. They can close them at will from the inside of the cupola. And they do that if they know there's debris coming around, they'll keep it closed, and, rather than take a chance on damaging their glass. Here's again Christopher Eddy from Italy. She's inside this cupola, looking at it, taking pictures. Got a camera here. It gives you an idea. Here's the 1 meter diameter window. Here's the 6 trapezoidal windows I was speaking about. And again, another view of Tranquility. You have Tranquility here. Is the cupola with all the windows closed, and then this pressure mating adapter number 3 just sitting here. Eventually, that will become very important for the very near future for docking of American commercial vehicles. So it gives you this gives you a good idea of like what it would be like to be inside. Like you can see a little guy in here. You can see an astronaut flying in here. Here's the Russian side, the Zvezda, with a fellow here. I like this one back here. Here's the Quest is over here. You have a guy doing an EVA, but it gives you a relative size idea of the size of how much room they have inside. Like I said, presently there's 7 people living in there. They have sleeping quarters in here for the Russians. We sleep in the Tranquility mode over here. In here you have the bathroom for our side, U.S. side. You also have exercise equipment, and then toward the end over here you have 4 different sleeping components. So 1, 2, 3, 4, and they all have, it's as big as maybe a telephone booth. I guess young people don't know what a telephone booth is, but most of us are older now. All right, we'll continue on. This is the last big module that this thing went up many, many times on the shuttle. It would berth or connect to a shuttle. They'd use the arm to connect it to a node, and then they would unload everything in science labs, and they'd put stuff that has to go back. Science experiments that are finished, and they'll put it inside of here, and then they'll undock this and attach it to the cargo bay and fly it back to Florida. So, but eventually they wanted to use it. The last shuttle that went up with this thing, they said, let's make it permanent. So they set it up, they improved on it, and now it's a permanent part of the space station. They temporarily located it here on the bottom of Unity, but that wasn't its final location. this is its final location here, the yellow color. So you can see our Tranquility here. So again, here's your setup so far. You got the Zesda, Zarya, Unity, Destiny, Harmony. Here's our Ham Shock, Columbus. Here's the big Kaibo for Japan, and then we have Tranquility here. And now they left this piece. They use this for a lot of storage and things like that. So they really need that piece. Let me continue on. Here's a good view of. So now Shuttle's gone. Now that Shuttle was retired, but now we have to depend on commercial vehicles going up. And here's a Dragon going that's docked to again one of these pressure mating adapters. You can see it's solar panels, and you know, like right now we have a crew of 4 that went up in this that are up there now. And this is the crew. This is where the crew would sit when they launch, and then they dock, and they don't berth. They dock with this thing, and they climb through this, and then they're into the space station. In the back, they call this the trunk. When Dragon comes back, this is the only part that comes back. This part eventually burns up in the atmosphere, but since it's so big, and plus they use it for solar panels, for flying up and flying down, they have power. In the back, they have this trunk. They could bring things up. Right now they're bringing up more solar panels, but I'll show you that in 1 second. By the way, this is an HTV. Like I said, this was one of the ones by Japan. Like I said, they put 9 of them up over the 10, 15 years. So this unit up here, this spacecraft up here is called the Starliner. Within about, I think, July 30th of next month, they're sending this back up again, up to the space station. It's going to be uncrewed. Eventually, we'll have a crew, but Boeing wants to test out the Starliner. Will eventually hold 4 people. If this works out and docks with the space station all by itself, undocks, flies all the way back, and lands on land, by the way, it has a capability of landing on land in New Mexico. And if everything is fine, they will relaunch it again with a crew of 3 and eventually a crew of 4, but a crew will go up at the very end of this year. So that's why I show that as well. So, and the back down here with these round solar panels, that's Cygnus sticking out. Cygnus is another cargo vehicle. All right, we'll continue on. Again, like I said, in the back of that trunk of Destiny, of Dragon, they put this at one point, and this is the Bigelow, or the Bigelow Expandable Activity Module, and launched on a Falcon 9 rocket, and this is what they hoped it would look like by the time they were done. Anyway, it launched. The Canadian robot arm took it out of the back of Dragon and installed it onto the rear-facing port of Tranquility, and it looked like this in the beginning. And they inflated it with nitrogen. The astronauts did it on the inside, and they inflated it and got bigger and bigger and bigger, like a big balloon. And by the walls are like 8 inches thick, so it's very, very thick walls. And this thing inflated. They liked it so much. After, it was supposed to stay for 2 years as an experiment, but it worked out so good. No leaks, no problems, radiation proof. That they now leave it for storage, and they do experiments inside of it. Give you an idea of the size of it. It's not huge. The existing crew that was there, 6 people go inside, to give you an idea of what that looked like. That's when it was first installed. And that's what it would look like on the outside. This is, of course, an animation of what it will look like. And you could see here's a Dragon cargo vehicle. They don't have the solar panels anymore on a Dragon vehicle. Now they put the solar panels permanently on the trunk piece. But there you go. Eventually, this piece would be changed out too. This is that pressure mating adapter number 3 that would be put onto the zenith or port looking up. Coming out of Harmony node to eventually accommodate crew vehicles being docked to the space station. So you'll have 2 ports for crews to dock, and you're going to have 2 ports for cargo to dock. So that was pretty good. Now, of course, main part of this for hams are to try to really contact the space station. So I got involved with my daughter, who's a teacher. She has a call sign N2WIN, and at the time, about, let's see, a little over 4 years now, she was teaching at St. Joseph's grade school, and she sent in papers to Aries, and eventually they had to send, you know, information what her school could possibly do for you know, for them, and then maybe they'll be chosen. Well, they were chosen to make contact with the amateur with the amateur radio on board the ISS, and that happened May 22nd, 2017. The astronaut on board was Jack Fisher, F2FSH. He was the one that they were going to contact if all worked out okay. And here's the school, and up here we use one of the rooms up here for demonstrations for the kids. The whole school got involved with, you know, that's what happens. The school gets involved with different space projects during the year, and one of the things that they would hope you would do is show them amateur radio, either HF or 2 meters or both. And eventually they sent papers back. You know, this Aries sent it back, and it was going to be a telebridge contact, which means no direct antennas looking up, but the antennas were in Santa Rosa, California. They had the call sign over there, W6SRJ, and Keon was the moderator. He was actually in England, M0XTD. You know, you hear his voice come up loud and clear with the people in the auditorium. And we used the gym, and you'd hear his voice, and he would tell everybody how this was going to work, how long the contact was going to be for, you know, about 12 minutes, and what to expect. It was very well done. Anyway, to show the kids anyway about amateur radio, you know, we put a G5 RV, put it through the window, and put it onto the roof, and then you know, there was a piece of wood up there. We tied the insulator to it, and we had two of the elements. I set them at 90 degrees. You know, we didn't have that much room on the roof for a full length of the for the G5 RV, but it worked. You know, you're able to we were able to get out like on 40 meters. You can see the ladder line coming through from the G5 RV. And we also had 2 meters go out there as well. We put a mobile antenna on the outside. And here's my daughter, Jen, Mrs. Bedorti, N2WIN, and we use the Yaesu 450D, this one over here, for demonstrations for the class. And then we had 2 meters as well. It was really cool because, you know, the kids really liked it. I was there for that, and they liked the HF. They liked, you know, I had bought a receiver and I put it on the desk where you could receive, like, you know, 40 meters HF, and all the kids know how the other kids sound. And when they would hear somebody that they knew, you know, talking through the radio trying to make a contact, they all got a kick out of that because, you know, their voice sounds more like Donald Duck, you know. So, and then here's WS2N with N2WIN with the rig over here, in the classroom that we used. And class after class would come in, you know, 2nd grade would go out, 3rd grade would come out, one right after the other. We went through the whole school. Here was the gym that we used, built it up with contacts. So, you know, we had everybody sitting there, kids, parents, and here's Jack Fisher, K2FSH. He was on the space station. We made the contacts with him, around 20 questions asked by 12 students on that day. And by the way, later on in the day, I mean, this guy had to do an EVA, but he had a schedule for us. He did the radio contact. You'd think he'd be worried about his EVA, but no, he did the ham radio contact. And then later that day, he's out waving, doing an EVA. And then we had the school here, or the students that did that. My daughter over here, and then the principal over here. So that was the story. And I had different rockets that have been sent up. You had the Proton rockets from Russia. You had the 3 different shuttles that went up: Atlantis, Discovery, Endeavour. Columbus wasn't built for it was too heavy for the space station. They didn't use Columbia module, the space station for that, for the to go to the space station. Then you had the ESA. They had the ATV. They used to send up a big cargo vehicle. They did 5 of them. Each one had, like, 13, 14,000 pounds worth of stuff over the years. But they did 5 and they stopped, and that was called the ATV, the amateur. No, that was the automatic transfer vehicle. I'm thinking of the amateur TV. And then, of course, you had the Japanese launch. They used the H-2B, liquid hydrogen, liquid oxygen rocket, to launch their cargo vehicles up. So, and then you have different ones. We have the Atlas that is sent cargo. We've had the Antares rocket from Virginia in Wallops Island that sent the Cygnus up. You have Falcon 9, of course. They send the Dragon cargo vehicles and now the crew vehicles all on the Falcon 9, and you have the Russian Soyuz sending either the Progress up with cargo or crew. And then this is what an exploded version looks like of everything that we covered. Again, the Russian Zvezda, the Zarya, the pressure rating adapter, and you can follow the line down to the node number 1, which is Unity, and then you have the Destiny Science module. Then you have the Harmony module, pressure rating adapter number 2 in the front. Here's where our our ham radio station is in Columbus. The Japanese series of modules that they had, and then coming out of Unity, you had the Tranquility module. Here's that thing that they blew up. The Bigelow Expandable module, pressure rating, the permanent multi-purpose unit, and then of course all your Truss sections that we discussed before. And I could give you a website to get that if you ever want to show. This one's up to date, so that's why I like it. There's a lot of older ones. So now what comes next after this space station? What comes next is the moon. Right now they have money planned and money handed out to start building this thing. This is the gateway. It will eventually be a space station in orbit around the moon. They'll have crews on there, not permanently, but they might have to be up there for months at a time. But I envision a point where you're going to have the crew up there, and you're going to have this thing, the Orion spacecraft, coming back from Earth, or going from Earth, docking with their space station around the moon, and eventually getting into like this vehicle this is part of the human landing system, which will go down to the moon and then come back up and come back to the space station, and you'll go back into Orion and eventually fly back to Earth. Anyway, eventually they plan on having an amateur radio on board this as well, including optical communications. So it's Aries is thinking ahead, which is very good. And then this is pretty much what it looks like today. The only difference is these new solar panels are going to be installed. Right now, collectively, you have 160 kilowatts of power. Your sun will lose, over time they degrade. So you're running, power starting to get a little lower, and plus they have a lot more modules than they planned on originally, so they need more power, and they're sending these up. They're called ROSAs, or International ROSA, ROSA, or Rollout Solar Arrays. So right now, just the other day, Dragon bought a set like this, and they're going to do 2 EVAs and attach it to here, and these times have gone by. The original solar panels are over 20 years old in design, and these are newer. So they're shorter, but they're twice as powerful as the old ones. So that'll bring you from, let's say, I think we're down to around 150 or so kilowatt hours. This will bring it back up to 205, which is more than what they had originally, once all of these are installed. And they're only going to do 6 of them, 3 here and 3 here. They're not going to do those. They don't need them. And so that's the story on that. For a copy for that exploded view, you can either copy this down real quick, which is www.nasa.gov, feature, facts and figures, with dashes in between, and you can get that exploded view to show either maybe somebody or a school might be interested, or you have the Aries website you can go to. You can always receive you put your 2-meter radio on if they're going overhead, and you never know if they're going to be transmitting. You hit them on 145.800. When we transmit, it's 144.49. Forget about this one. This is if you're in a different region. We're in region 2, so we transmit on 144.490. You can contact me at spacenetreport@gmail.com. Of course, most of you, a lot of you probably know that I'm on the TechNet every Sunday night, 8 o'clock. It's run by a terrific ham, Dr. Roy, AC2GS, and he's net control. And then later on during the night, usually around 10:15, I'll come on and do a space report of what's new in the space world. So that's pretty much it. Let me see if I can close this down. What do we do here? I hit the escape button, I guess. And that's it. Okay. Okay. Hello. Gary?
Very good. Very good. Terrific.
Okay.
Okay.
I got off. Okay.
Do,
well, many questions. I'm here, but
I was going to say, do we have time for any questions and answers that members might pose?
I have one. You mentioned there are cooling, I call them cooling towers, but cooling modules from the heat that's built up in the space station. What
Yes.
generates all that heat that they need a special, because I assume it's very cold out there. What generates all that heat that has to be cooled by specific modules?
You have 2 different sets of radiating. You see them sticking out, not solar panels. The other ones, you have some coming off that's taking the heat from the modules, and then the other ones are taking the heat from, you have the solar panels, and they go down to these voltage control units. So before they get into the space station, they're delivering a lot of heat with these massive batteries that are located out on the truss sections. They have to get rid of that heat. So that's why you see those big radiators on the end. But the ones near the inside ones are trying to get rid of the heat from inside the modules. It's actually, it's amazing. It's very hard to, the heat that builds up inside the space station is a lot. These are well-insulated walls, all kinds of mylar and everything in the walls. So any heat from electronics or anything that's inside that module has nowhere to go. So it's constantly generating heat. So they have it's all ammonia. It's not an evaporative system. It's not a real true refrigeration system. It's ammonia that's being pushed through, picking up the heat from inside the modules, and then being redistributed to the outside of the module. They've had some problems with leaks on the outside, and they've done a couple of EVAs to fix that. But there's a tremendous amount of heat that builds up that you can't get rid of. It's so insulated. It's like a super duper thermos, every one of those modules. So they need to get rid of the heat.
Thank you.
I could think of 6 things more that are also very hot. Human beings. They're very hot. They're very hot.
You put microwave on, you start heating things up. It all has to go somewhere. So they control that with those big radiators. So
Paul?
Yes.
I saw in an online squib recently that a piece of space junk slammed into the robot arm and punched a hole in the side of it.
Yes.
Did that damage the arm functionally, and are they going to fix it?
It's not damaged at all. In fact, they're not even sure when it happened. Generally, as time goes on, they do inspections. They have all kinds of cameras outside the space station, and they'll inspect different things, including the robot arm. And they didn't even know it was there, but all it did was put a hole in the insulation. it didn't damage the arm itself, so they don't have a problem with that. So there's no, they won't do anything with that. If there's a good book by Kelly, Scott Kelly. That, you know, he was up in space station for a year, and he says in that book that when you do an EVA, when he first did an EVA, he was surprised. He's looking at the handles. You can see these gold handles of the, you know, if you ever watch them do an EVA, they move along, they translate from one end to the other with their hands. And he said, you have to be careful because once in a while you look and you see a little chunk out of these handles and you know, on the station itself. So, you know, over time it does get hit with something, either debris or, you know, small meteorites, who knows what, but you know, they have to be careful, and they let NASA know about it, and then NASA will let them know when you're out there, when you get the handle 258, you know, be careful, that one's got a chip in it.
Thank you.
Is there free access for everyone throughout the whole space station?
Yes, there is. They naturally, the Russians always cook and everything on their side, and then we have our everything on our side as well. They say on Fridays everybody likes to go over to the Russian side, and they'll bring food with them from the American side. But yeah, there's free access for everybody to go from one end to the other. But they tend to stay in their own areas, you know. And it's like you can see it's big, so that's a story with that.
And what's the continuing source of oxygen on the space station?
Okay, the oxygen is recycled. They have these regenerating units as big as a transmission, bigger than a transmission of a car, and they suck the air out, the carbon dioxide that's out, and then they'll separate the carbon from the oxygen. Yeah, they'll save the oxygen. That's one method. Also electrolysis. Russians really are big on that side. They'll actually take water and separate the two to get more oxygen. And of course it's resupplied as well by when the vehicles come up, they'll actually bring up high pressure oxygen tanks, you know, and that's pretty much what they do. And it's enough to keep them going. They never seem to be short of. I never hear they're short of it. Sometimes they'll get a little too much carbon dioxide in the unit, so they want to bring another one of those carbon dioxide removal units up. I think there's 2 on the station. They want to bring another one up, especially with more people. You know, now they have 7 people on a regular basis, Rich. So.
Okay.
How much
Any
food
other?
is on the station at any given time?
They have a 6-month supply all the time. So, I mean, at one point years ago, they had cargo vehicle that went up, Dragon CRS number 7 was going up, and it blew up before, you know, as it was going up. So that cargo vehicle had all kinds of supplies and food on board, and they had to figure out, and that takes time to figure out before they relaunch. And then in October of 2014, it was the same year, another sickness blew up, launching from Wallops Island, Virginia, and on an Antares rocket using the older rocket engines. They don't use them anymore. Because of that reason. So next thing you know, they started to worry. And then sure enough, a Progress vehicle had a similar problem. So they started thinking about rationing food, but they never got that far. But they have plenty of food on station. Any other questions?
Yeah, Paul, we've heard of them operating phone and digital modes. I wonder, has anyone made a CW contact from the ISS?
I've wondered it myself, and no, they haven't done it. You know, I guess you can do MCW, Ken, you know, maybe, you know, that would be good, you know. But no, they haven't done it, or true CW contact would even be better. But, you know, they're running FM, so they have slow scan TV. In fact, this was today, the 9th and the 10th. The Russians are sending right now slow scan TV down from the Russian module, so anybody else on Earth can copy it. I don't have the software for it, but you know, it's probably a picture of, you know, Yuri Gagarin or something. But that's what they're doing. So, okay. Any other questions? Okay, I guess not. If not, we'll turn it back to you, Harry. KC2FYJ. Thanks for letting me do this, and anybody wants to talk to me, we're usually always on the TechNet, like I said, on Sunday night, or sometimes during the week, or you could email me.